ABC with circumcircle omega. Okay. I wonder if I've done this problem before. I hope I didn't. So D is on arc BC. And the tangent at D, I feel like this might be like the third time I've done this. I hope not. It looks really, really familiar.
Yeah, I think it is. We stumped on this in the last session.
Yeah.
We couldn't do it like twice or third time, I think.
Yeah. Okay. I'm gonna move on to the next one just because we've done this problem a lot. Let's check this one. Okay, so we have a scalene triangle ABC, orthocenter H, and circumcircle gamma. Here's a circumcircle. Let's AH. Okay, so really what I could do is it says where AH meets the circle. So I could just call that D, and then I could just reflect it and let that be H. So this is D. Let me reflect it over BC, and then we got H. Even this problem looks a little familiar, I feel like. AH, BH, and CH meet it at E and F, and EF meets BC at P. Yeah, okay, we did this one before. Okay. All right, let's see if I can find, I'm going to open up a book. Let's see if we can find a good problem in this book. So this is the book by I3435. He gave me his permission to use it on the channel. Let's see. Do you guys have a suggestion for which of these problems we can do? $313 look. Okay, I'll just choose the first one. So looks kind of hard. What is stems? I've never heard of this stems competition. All right. What is ETC? Oh, Encyclopedia of Triangle Centers. That might be fun. If we solve this one, then I'll try that. Okay, so I'm just going to put the source. This one is stems 29, category B, P6. Maybe this is like a new contest or something. I'm not going to tech it up just because I'm lazy. So we have triangle ABC with circumcircle gamma, and the end circle touches it at D, E, and F. Oops, not that. So here's the circumcircle, and I'll draw the end circle. Let me check the chat. Yeah, that might actually be a good source of problems, just using the Encyclopedia of Triangle Centers and finding out random things. Okay, so this is D, E, and F. Q lies on EF, and R lies on the circle. So DQ is perpendicular. Oh, this looks a lot like a Sharky Devil type configuration. So DQ is perpendicular to EF, and it kind of looks like IMO. Well, I was going to say IMO 2019 number 6, but not exactly. So R lies on the circle. So this is R. R lies on the end circle. AR, this might be like a well-known idea. It looks like IMO 2019 number 6 kind of. So AR meets it again at, it meets the incircle at P and the circumcircle at S. AQ meets BC at T. Almost looks like AQ is perpendicular. Oh, by the Iran lemma, oh no, AQ is not perpendicular to BC. It meets BC at T. And M is the midpoint of BC. And O is the circumcenter of MPD. We want to show that O, T, I, and S are collinear. So I see a lot of stuff in the chat. Hold on one sec. Let me hide.
I think that ITS, that collinearity is well known.
Okay. So IT and S, the fact that IT and S are collinear is kind of well known. And then to show that O.
Michael, I don't know if you read the chat, but the S is the mixed linear in touch point.
Oh, no, I haven't read it yet.
And that is, let's say, well known.
Okay.
Yeah, we can do a little computing to show that IT and S are collinear, since we already know that S is the linear tangency point.
Okay. So these three are collinear and they kind of pass through the midpoint of arc BC, right? We just need to show O lies on that. So could we show O? Yeah.
I think if we can prove that TP is also the tangent of omega, then we are done.
Okay, so if we can show that, what's tangent to omega, or
TP.
Okay. Oh, T. Sorry. Oh, can we define? Hold on one sec. Let me first. Okay, so we'll intersect EF with BC. Oh, I wonder if EF is the radical axis of these two circles. Yeah, yeah, it is. Okay.
It looks like M isn't important at all, the midpoint, because if we took like any point, and then took the circumcenter of, let's say M, that is the point, random point is
Okay.
M, then the circumcenter of MPD would just lie on the perpendicular bisector of PD.
Okay, so you're saying that this whole line is just the perpendicular bisector PD.
Yes.
Ah, that's kind of silly. Okay.
I don't know then why did they give the midpoint.
Yeah, they were just trying to trick you, I guess. So once you know that IP and S are collinear, is it well known that TS is the perpendicular bisector of PD?
To me, isn't. So
Okay.
I think we should prove it.
Okay.
I mean, we can't say like the whole problem, it is well known.
Okay. So yeah. Well, obviously I lies in the perpendicular bisector PD. And can we show that S or T lies on it? So yeah, that would be the same as saying that TP is tangent to the end circle. Is RQST cyclic? Let's check. No. So we want to show PD is the polar of T, right? So yeah, we have to show that either S or T lies on the lies on the perpendicular bisector of PD. Let's see, does SD, because it's well known that SD passes through this, like, it's well known that if we let SD intersect the circle at J, then AJ is parallel to BC. So yeah, if that were true, then it would follow because yeah, basically it's well known that angle ASG is angle GSJ. So S lies on the perpendicular bisector of PB by symmetry.
Oh yeah, that is it.
Yeah, we can do that by, I think there's a way to compute that we can use computing to prove that SA and SJ are orthogonal with respect to BSC.
Yeah. Okay. So should I even write up the solution or you guys want me to try another problem? Another problem. Yeah. Or we could go back
I
to the
think
old.
like this one is just like a bunch of well-known facts, like just
Yeah, no, I agree. It's a lot of well-known facts. Let's see, what chapter is it? Let's from ETC. Encyclopedia. So yeah, we've never done this before. Where we just take it from here. Yeah, what do you want? You want me to just pick a random triangle center? I don't know about this. I think this might be a little too weird. No, there's no problems. You just, it tells you like for example, this is the in-center, and it tells you, for example, that it's all these different things. So like it would tell you that it's the center of the atom circle, and then I'd have to look up what that is. And then, yeah, so I don't know if you've ever seen this before, but yeah, I'm just gonna take, yeah, problems from the book. I agree. Let's see, what about this one? I kind of like this one. MMO shortlist. So let's think about that. DF and DE. Oh, I think this one might be too easy, actually. What about this one? I don't know if this is well. Have you guys seen this one before?
What is the Arctic triangle? What does that mean?
Oh, we did that on a session. Okay. What about this one? Let's see if we can find a new one. Okay, this one I don't think we've done, so I'm gonna try this one. Okay. Okay. Let me add a space here. Circle at the non-DL point. The non-D point L. Okay, so let me just press enter. Okay, so we have a triangle ABC, and the foot of the altitude from A to BC is D. Okay, so we draw D, E, and F, and then we draw the intersection. Oh, is I the in-center? Because I don't even see I defined in the problem. I'm going to assume I is the in-center. Let's check that in the book. Is that really how it was stated? Sorry. Yeah, okay, I'm going to assume I is the in-center. And so we have D, E, and F. This is X. The circle with diameter AD. Interesting. So let's draw that circle. Sorry. It intersects DE at E naught and DF at F naught. Okay, so basically E naught and F naught are, by Blanchett's theorem, they're symmetric. So we'll call this E naught. I don't really like that notation that much, but it's okay. So yeah, they're reflections across AB. And let it intersect the circumcircle DEF at L. And then we're going to draw the incenter. This is weird. Maybe he meant to say let GL intersect DF at K. I don't know. Yeah, let me draw the circle through X, D, and K. Or X, D, L. We could stick with this one for now. Let's see if we can solve this one, and then maybe we could do that one on the next session. Okay, so if we let GI intersect EF at a point, that doesn't look like it would lie on the circle, right?
This isn't even stated correctly, like we don't know really which points are which, so shall we just try the Geo King's problem?
Okay, yeah, Geo King, you can give your problem. DEF at L. Yeah, okay, so, all right. I have way too many tabs open. All right. Yeah, that problem is just weird. Let me see. Oh, and the actual problem, it says E prime. E prime and F prime, but yeah. No, something's weird about it. I'll have to ask I3435 about it. Okay. So here's a problem by GeoKing. All right. See who's still on. Con. Okay. Let the B altitude intersect CA and the C altitude intersect AB at E and F. I'm going to make it look a little better. D is, oh, we also draw the A altitude. Okay, so that's D, E, and F. D, E, F. The midpoints of the B and C altitudes are R and S. So RS is basically the Gauss line of that quadrilateral, right?
Actually, I think we denote the wrong midpoints.
Oh, really? Sorry,
It
let me
should be
check the chat.
CE and BF.
Okay. Okay. Oh. Denote the. Oh, so I was doing this part, but then later it says the midpoints of CE and BF, right?
Oh, okay, okay. I'm sorry.
Oh, it's all right. Midpoints of BE. Or maybe he switched them. I don't know. Maybe it should be the other way. I'm going to first do it this way. So U, and this is V. It almost looks like that's a parallelogram, right? I don't know if that's easy to, is that, yeah, so maybe we could prove that that's a parallelogram. And then let
Because of the midlines, it is.
It is. Yeah. Let the feet of the perpendicular from D onto UV and RS be T and W. Okay. UV and RS. And then we want to show TW is parallel to EF. So this is T. And this is W. Maybe it looks a little like a homothety somehow. Oh, whoops. What did I just do? Did I delete the problem? All right, now let me redraw everything. The E, C, F, midpoints of CE. So the feet of the perpendicular from D onto UV and RS, or T and W. And we want to show that TW is parallel to EF. Okay. What's a good way to draw this? Let's see. So yeah, I want to draw that parallelogram. It would probably look a little nicer if that parallelogram wasn't so flat. So I think this is a good picture right here. So yeah, we have a little parallelogram there. And then we draw the feet of the perpendicular from D to the two diagonals of that parallelogram.
Oh, we need to prove that TW is parallel to VR, which is parallel to SU.
Okay, so yeah, it's parallel to both of those.
And
then,
those are, of course, parallel to EF because of the midline, because they're midlines.
yeah.
So we just have some ratios, I think.
Okay. So here's the center of that parallelogram.
Can you draw the altitude from A onto EF? I think the W passes through that point.
Okay.
And more, yeah, you label it. Can you label that point?
This point?
Yeah, yeah. I think W is the midpoint of HD.
Um, DW passes through.
Yeah, and W is the midpoint of HD.
Okay. W is the midpoint of DH. Interesting. So I guess I'm wondering, why?
Somehow we gotta, call them intersection of BT and EF and try to prove that T is the midpoint of that segment. I think that's how GeoKing wants us to do that.
Okay, hold on one second. So I'm a little confused. So because RS is different. Okay. So I'm sorry. Tell me that. Say the next step again.
I haven't solved it yet, but I think that if we know that W is the midpoint of DH, so we should call the intersection of BT and EF and trying to prove that WT is the midline of that triangle.
Okay. So yeah, basically we would draw this point, and then we want to show that TW is the midline. Interesting.
Then draw the orthocenter. The
Of
H.
ABC?
Yes.
Okay. Let me just make it farther away from R. Okay.
Then we have to prove only that HI is perpendicular to EF.
Okay.
And then it will be solved. Then we can prove that the T is the midpoint of ID.
Okay.
It is not obvious, but I have done a problem like this before.
Okay.
Yes.
Interesting. So yeah, GeoKing, apparently he had the same solution in mind that we had. Even though we haven't solved it yet, like all our ideas are this kind of what GeoKing was thinking. Yeah, once we solve this one, we could try it. We could try a harder one. Is IF equal to JE? Let's see.
Yes, that is true, but if this were true, all the other things. Because that is like the in-center, X-center stuff.
Okay. But what's the what would be the in center and what would be the like wait, or why would that be? So like is H is the
H.
in-center of DEF, right?
Yes, and A is the X-center of DEF.
Ah, okay.
It's that duality.
Yeah. Interesting. But yeah, we still have to prove that HI is perpendicular to EF. We're close, but yeah, it looks interesting. All right, I'm gonna make this diagram look a little better. So DI and DJ. Okay. So we know W is the midpoint of DJ. How did we prove that W is the midpoint of DJ? Oh, we haven't.
Yeah, but it's true. I think we can prove that. Let me think it for a while.
Okay.
Actually, proving that DJ is perpendicular to RS is easy, but we need to prove that it bisects DJ too. So,
We need to show that W is actually the mid, like we need to show RS is the perpendicular bisector of BJ. We know it's perpendicular, right? But not bisects it yet. That's kind of interesting. So yeah, once we prove it for RS, the same, probably a similar proof would apply on this side, right? So yeah, maybe it's worth drawing the midpoint of BC. And then, like we know KVLU is a parallelogram. We want to show IVDU as a kite. So KU is parallel to CF. It almost looks like KR passes through that point. Are KT and H collinear? It almost looks, yeah, it looks like KH and T are collinear. I'm not sure why. And then also, oh no, we can't say anything about KR, but KH and T look collinear. I wonder, oh, okay. That's a good point.
I can prove that W is the midpoint of DJ.
You can prove W is the midpoint of DJ.
Yeah, so first we gotta, you have something like so that the configuration is easier to, you know, to solve. Anyway, I'll just do it. Okay, so let's call the reflection of D over R.
Okay. The reflection of D over R.
Yeah. And so we have the BDED prime is a parallelogram.
Okay.
So BD must be equal to ED prime.
Yeah, so
And,
BD is equal to
also-
ED prime.
And also we'll have ED prime is parallel to BD.
Yes.
So we have angle JED prime
Mm-hmm.
is 90 degree minus angle A. Can you label the intersection of AD and EF?
AB and
AD
AB.
and EF.
Oh, sorry.
Um,
Did you say BC and EF or?
AD and EF. AD.
Oh, AD, sorry. Yeah, I don't think, yeah, okay. So, all right.
So we can see that angle JED prime is 90 degree minus angle AME,
Okay.
and it is equal to angle it is equal to angle angle DAJ.
Equal to angle what?
DAJ.
DAJ. Okay. Okay.
So noticing that AEF and ABC are similar, and AJ and AD are the altitudes. So we must have that JE over JF is equal to DB over DC, and it's equal to AJ over AD.
Okay.
So we have the two triangle JED prime and triangle JAD are similar.
Okay. JED prime and JAB.
So we can, so by symbol angle chasing, we have GD prime must be perpendicular to JD.
Okay. So let me first outline it. So first we show that JED prime is similar to JAD. That's the first step, right?
Yeah, that's right.
And then once we show that, JAD, and then what's the next step after that? Okay, so JD prime is perpendicular to JD. Yes. Okay, so So that's true. And then what's and then how do we get that JW equals WD?
Because in triangle D prime J, we have JR is the median of the right triangle. So we have J, we have RJ must be equal to RD.
Okay. All right.
And
So
similarly, we can put that SVA equals SD. So
all right. So I'm going to write this out step by step. So let D prime, we define D prime to be the reflection of D, sorry, over R. So then BD prime ED is a parallelogram. Okay. And then we can calculate angle DE prime J is equal to DE prime M, which, okay, so we want to show DE prime J equals JAD, and that's kind of just an angle chase because, yeah. So first we have angle DE prime J equals 90 minus angle EMA. EMA, which is equal to JAD. Okay, so that's one of the angles. And then for the other angle, I think, did you use ratios after that? I think you might have used ratios.
yeah, I did. I use ratios.
Okay, so it was D prime E over EJ. Did you say that was like BD? Okay, so how did you do the ratios after that?
I think it is, well, let me recalculate it.
Okay.
So we have JE over D prime E
Mm-hmm.
is equal to JE over BD
Mm-hmm.
because the parallelogram thing.
Yeah.
So moreover, GE over BD is equal to AJ over AD.
Oh, because they're
AD
similar triangles. I see.
Yeah.
Ah, okay. So we have it's JE over ED prime is equal to BD over ED prime, which oh no, we want EJ. JE over ED prime. Oh, sorry, it should be JE over BD. And that's AJ over AD. Okay. And so for that's how we get the similarity. And once we have that, then that means JED prime is similar to JAD. That means that JDD prime is similar to JEA. Right, is that right?
Yes, yeah, that's right.
Okay. But that's weird because I would think, oh yeah, yeah. Okay. Or no, this is just E, JEA. And that implies we have a right angle. So that means that angle JD prime B equals 90. Let me see if I can put this on a new line. See if that works. All right. Or no, D prime JD. Okay. And then once we know that, it follows that then it follows that W is the midpoint of DJ. And then there's probably a similar argument that shows that T is the midpoint of DI. I'm not sure. Is there like another parallelogram that we make? Like, does this, I wonder if there's like another argument that holds by symmetry, kind of. So we reflected D over R. Then we could try reflecting D over S and see if it's like, we're reflecting D over V. Yeah, we probably want to reflect D over U or V. Let's see how that works. So if I reflected D over U, you just barely see that point there. There we go. Call it X. So yeah, then we have a parallelogram here. And so we would want to show like d prime I x, or no, we'd want to show x I I don't know if it would be XIF or yeah, I'm trying to copy the argument, but it's probably a little bit tricky. Maybe XIC. Okay, so here we had D prime JD was 90. Maybe I want to show XID as 90 degrees. Let's see if that's true. Yeah, okay. So instead of D prime JD, now I want to show XID as 90. So basically that would mean, what would that mean? So basically we want to show that a spiral similarity about D, we want to show ABD is similar to XDI. Is that right? That's 11.54. Yeah. It's probably a similar angle chase, I'm guessing. How did we do it before? So basically we want to show that XBD, let's think about this. So we want to show that do we want to show that IDB is similar to IXA? I think that's what we want to show. Yeah, I'm just trying to copy the argument without really thinking about it. We want to show, let's see if that's actually true. No. Okay, so yeah, I think we can do a similar thing with point X, but we're out of time here. So I'm going to stop right here, but yeah, I encourage you all to see if you can figure out the solution with point X. So thanks everyone for participating today. We had a good number of people this time. And next time I'll probably take more problems from I3435's book, or see if I can find some other harder source. But thanks Geo King for proposing this problem. And thanks everyone else for watching on YouTube. So if you'd like to join future sessions, you can feel free to email me at mgreen801@gmail.com. It's going to be in the description of my video. So the sessions are on Sundays at 8 a.m. US Central Time. Thanks and have a great day.